Every one of us has a smartphone, which is a small computer and you can do lots of things with it. But do you really use all of your smartphone's resources all the time? What if you could share a little bit of these resources? Now envision a near future where you have multiple smart devices with small computers all around you. And these devices could communicate using technologies such as Wi-Fi or Bluetooth. What could you do with them? If you look at smartphones alone, on average a person actively uses their smartphone for about 5 hours a day. This means that computing resources are being wasted for the rest of the 19 hours in a day. Given that there will be around 2 billion smartphones worldwide by 2016 and that 1 million smartphones could provide up to a petaflop of computing power, we have about 2000 petaflops of computing power available worldwide for 19 hours a day. Even if we make the conservative estimate that we only use half of each device's compute power, it still means we can garner power equaling 30 supercomputers like the world's current top supercomputer. If we also take into account the smart devices present all around us, we find that there is an enormous amount of computing power available for us to use. The point is, there are plenty of idle resources on small devices which, when scaled, can provide us with a lot of computational power which can then be used by some entity with a lot of work to do to distribute this work among many weak devices. In order to test such resource sharing among smartphones and other smart devices, we built a platform that allows distribution of tasks from a single entity, known as a dispatcher, to either an ensemble of devices such as a femtocloud managed by a controller, or to individual smartphones and IoT devices themselves. In our system, the dispatcher offloads matrix multiplication tasks to individual Edison devices and to a controller of a cloud of Android devices. For the demo, we use 2 Edison devices and a mobile cloud of 2 Android devices. The dispatcher and the controller are running on desktops. Once the devices register to the dispatcher, it starts sending them tasks. This is the dispatcher's logs regarding the tasks it generates and regarding the worker node's presence. The other 3 terminal windows show the dispatcher's communication with each worker node, that is, the controller of the mobile cloud and the 2 Edison devices. This screen displays the mobile cloud related logs. The top terminal window has the controller's logs regarding tasks it is receiving from the dispatcher and regarding members of the cloud. The 2 terminal windows below log the controller's communication to the Android devices. We also built a real-time visualization tool to view the resources provided by IoT and Android devices. These devices send periodic updates with the current status of their CPU and memory usage to the visualizer.